All right, second problem on the April 2nd homework. We have this little picture graph of this car traveling or something that's a car traveling. This is the time in seconds, and this is the velocity. So this is the velocity graph again. First question was to find the integral from 0 to 24 of the velocity. It's just area under the curve. You use the trapezoid formula. I'm sure you guys all know the trapezoid formula, right? 1/2 times the height times base 1 plus base 2. You can also break it up into triangles, rectangles. Anyway, I got 360 meters for that. Asked me to interpret that. Normally when you integrate velocity, you get displacement, right? So be careful about that, because if you have positive velocity, negative velocity, you could wind up back at 0, so it's just displacement. It's okay in this particular problem to call it total distance traveled, but because the velocity is always positive, so if it's always positive, it is a total distance. Technically, displacement's the right answer. Total distance traveled is what you get when you integrate the speed, but either one in this case would be okay. 1 point for the right answer, 1 point for the interpretation. Second question was to find the derivative at 4 and the derivative at 20, or tell they don't exist. Derivative of 4 is right there. It does not exist because the slopes are different. Left-hand side slope is different than the right-hand side slope. 1 point for that one, I think. Yeah, 1 point for each one of these. And the slope at 20 would be right here. It's just the slope of that segment, which is, I just did rise over run. So I did a 20 minus 0 over 16 minus 24. Got negative 5/2 meters per second squared. 1 point for that one. Also, actually 2 points. 1 point for the correct unit on that one also. So, next part's very similar, I think. The third part asks you to draw a piecewise function of the acceleration. So acceleration is the derivative of the velocity. This is the velocity. Derivative of the velocity is just going to be the slopes here. So it's a piecewise function because you got 3 different slopes. So this slope here is 5, 20 over 4. It's 5 between 0 and 4. Then it's 0 between 4 and 16. And then it's that negative 5/2 again, like it was from the other one. From 16 to 24. It's not defined from 4 to 16. It's 1 point for this and 1 point for saying that, because that is part of the thing. If you leave that out, you got to say what's going on at 4 and 16. Last question was to find the average rate of change. Average rate of change is just slope. So average rate of change of the velocity is just the slope. It was from 8 to 20. So it's just the velocity at 20 minus the velocity 8 over 20 minus 8. The velocity at time 20, that's right in there, so I need that point, but it's just the midpoint of that. Pretty easy to find. Sorry, velocity at 20, yeah. Velocity at 20 is 10. It's halfway here, so it's 10. Velocity at 8 is up in here, which is 20. And then over 20 minus 8 is 12, so you get negative 5/6 meters per second squared. 1 point for that. And the last question said, does the mean value theorem guarantee a value for C such that V prime C is equal to the average rate of change? That is the mean value theorem for sure. That's exactly what it says. Remember, the mean value theorem talks about if you have this and you draw a secant, that you got to have a parallel. But it only works if the graph's continuous and differentiable. So it says, does this work for this graph? And it does not work for this one because the velocity is not differentiable at those 2 points. 1 point for getting the right answer to that one for 9 total points. So that's it for those 2 problems.